In this session, we are going to learn another HackerRank problem called diagonal difference. This problem is based on matrices. Let's try to read the question and try to understand what the problem says. It says that given a square matrix, calculate the absolute difference between the sum of its diagonals. So we have principal diagonal and then we have secondary diagonal. We need to calculate the sum of the principal diagonal elements and the secondary diagonal elements, and then we need to find out the difference. And while calculating difference, we need to calculate absolute difference. When you say absolute difference, it's like the difference in the values excluding the sign, right? So they just given a simple example like left to right, also called as the principal diagonal elements. It is 1 plus 5 plus 9, which is 15, and the right to left diagonal, which is also called as secondary diagonal elements, we have 3, 5 and 9. The sum of that is 17. Now if you just perform 15 minus 7, it would have given you minus 2, but since we need to perform the absolute difference of this, we only consider the value without the sign, so we get it as 2. This is a task to be done, right? I hope the problem is clear. Okay, let's try to see, okay, if I represent in matrices, right, what will be the indexing of the principal diagonal elements and what will be the indexing of the secondary diagonal elements. Right, now I have taken another example out here. This is a matrix. Okay, this is my principal diagonal elements, right? And let us try to look into the indexing, and let us observe mainly on the indexing of the principal diagonal elements. If we can just observe here, okay, the principal diagonal elements, the row value as well as the column value, right, it is same, 0 0 1 1 and then 2 2, right? The row index and the column index is same for principal diagonal elements, right? Okay, when you want to calculate this, you just need to make sure that you just run a loop wherein the row index starts from 0 and column index and row index is same, right? So you don't require a nested loop. Fine. Okay, let's try to write a program to calculate the principal diagonal elements. Now the first thing we are going to read is the order of the matrix, and once we read the order of the matrix, we need to create a square matrix, right? It's always a square matrix, only then we can calculate the principal diagonal, secondary diagonal. Okay, and then we'll try to write a code to read the entry of the matrices. This is the number of rows, and then we have the number of columns. The inner for loop is for the number of columns. And inside this, there will be a statement to read the values. This is my reading of the matrix. Right? I'd like to keep the reading separately, and after that I'd like to calculate the principal diagonals. Okay, now sometimes, okay, we basically write something like same two for loops, and then we say that if I equal to j, then it's the principal diagonal elements. Now we can do this, but the only problem with this is, assume that you're working with a 3 cross 3 matrix. Okay, the overall number of times this operation is checked is 9 times, right? 3 times outer for loop, and each iteration of the outer for loop 3 times inner for loop will be executed. But we know that we don't need to really execute 9 times, we need to only execute 3 times. Okay, or in case if it is n cross n, it is n times and not n into n, right? So what I'll try to do it is, I'll not use this. Okay, I'll just use this single for loop wherein it just run from 0, then 1, then 2. Now I just need to use matrix of I of I, right? When the value of I is 0, it will be 0 of 0. When the value of I is 1, it will be 1 of 1. When the value of I is 2, it will be 2 of 2. Clear? If you want to print, you can print the indexes. Now once you get this, we just need to access the data, add up to the principal diagonal sum. I'll just say principal diagonal, initial I'll set it to 0. Take this variable, just keep adding that value to this. Principal diagonal elements plus equal to, please observe this plus out here, it is component assignment operator. Fine, this gives me the principal diagonal elements. So let us try to run this particular program and just say this is my principal diagonal elements. Fine, now let me try to run this code. Compile it, run this, I'll just enter the order as 2 cross 2. Right now I'll be entering the elements 1, 2, 3 and 4. Okay, the principal element says 1 and 4. 1 plus 4 is 5. Got it? We got how do we calculate the principal diagonal elements. Fine. Now let's try to understand how do we calculate the secondary diagonal elements. Now the secondary diagonal elements is this one, 8, 6 and 4, right? And now we need to observe what is the pattern followed by the indexes out here, right? So if you can just observe that this is 0, then 1, then 2. The row values are like 0, 1 and 2, but the column values, if you can observe, when row is 0, column value is 2, right? Okay, or you can just say that what is the order of the matrix here? It is 3 cross 3. So the starting value of the column is 3 minus 1, which is 2, and then it keeps decrementing. And one more way what you can observe is the row plus column will be equal to n minus 1, right? So you just need to find out an expression wherein you get the row values like 0, 1, 2, and then the column value has to be calculated through an expression, right? And then you just need to run a loop. Again, you need to run a loop only n number of times, not n into n number of times, right? This is for my secondary diagonal. Initially it will be set to 0, and as I said, I'll just be requiring one for loop, not two for loops. And after this, our row index is fine. I'll just get it as with the help of I. J, okay, or you can say the column index I need to calculate through an expression. So I can basically say n minus I minus 1, right? N value is 3 in this example, right? So n minus 0, that is 3 minus 0 is 3 itself. Okay, 3 minus 1 again is 2. When I value is 1, right? 3 minus 1 is 2, 2 minus 1 is 1, right? Once you get this, okay, you can just keep adding up this. Okay, again you have to use the component assignment operator here. Then I would like to print what is my secondary diagonal elements, and once the principal and the secondary diagonal elements are printed properly, then we will just learn how do we perform this difference and how do we perform the absolute difference. Fine. So I'd like to print the new line here. Fine. Now let's compile the program and run it. I'll again consider 2 cross 2. I'll take up 3, 8, 7, 6. Now what we got? Principal diagonal is 3 plus 5 is 8. And secondary, what happened? I just used the wrong variable while printing it, right? That's the problem of copy pasting. Okay, so I've done the changes, and whenever you do any changes, please make sure that you save it and then recompile your program, execute it. I'll just say 2 cross 2, right? 2 plus 7 is 9 and 4 plus 3 is 7. So you calculated the principal diagonal and the secondary diagonal. You want to calculate the difference. So difference of this will be principal diagonal minus secondary diagonal. Okay. Now this is the difference. Fine. I would like to print the difference. This is my difference. Okay. Now I'd like to recompile this, execute this. Again, I'll take up 2 cross 2 only. So what we got? Okay, 2 plus 6 is 8. 8 minus 7 is 1. Again, I'd like to run one more. 2 cross 2. Let me just say it is 2, 8, 7, 4. What is 2 plus 4? 6. 6. The other one is 15. 6 minus 15 is minus 9. But I don't want to consider the negative sign. So I need to calculate the absolute. In order to calculate the absolute, we have a function called as ABS. ABS. Done. So then I can just say this is my absolute difference. In order to use the absolute, we have to include the header file stdlib.h. right? In case if you know the function, if you don't know what is the header file, you can always see the man page. You can just write man space abs, you'll get to know what is the header file to be used and then use that. Fine. Okay, so I've used the required function. I'll try to recompile your code, execute it again, 2 cross 2. Right, absolute difference was -1, sorry, difference was -9, absolute difference is 9. Right, now what are we supposed to print in the HackerRank environment? We need to only print the absolute difference. We are not supposed to print anything else, right? All these intermediate values was for our better understanding that was the principal diagonal elements calculated properly or not, secondary diagonal elements were properly calculated or not. So let us try to take this program, let's paste it here. Done, initial test cases passed, submit it. Done, guys. What a simple program, wherein this was the reading, and then just you need to observe this principal diagonal, secondary diagonal, and the absolute part. Fine. Thank you.